Greetings, everyone. We are the Group Optimist. We will be showing you the topic presented today about arithmetic using non-decimal systems and subtraction methods, including complementation. But first, binary addition and subtraction is similar to the decimal number system. The binary addition and subtraction is similar to the decimal number system, but the main difference between these two is binary number system uses two digits like 0 and 1, whereas the decimal number system uses digits from 0 to 9, and the base of this is 10. In this presentation, we're going to focus on operations associated with binary numbers. How do you add two binary numbers together? How do you subtract them? All videos used in this presentation that we are not the founding design has the remaining rights to their video. All materials are only used for educational purposes only. Let's review the basics. 0 plus. 0 is equal to 0. 0 plus 1. Or 1 plus 0 is equal to 1, and 1 plus 1 equals 10. Since we are using the binary system, we don't say 10. We read them as individual digits for 10. Let's say 10 for 101. We'll say 101. Suppose you would like to add two binary numbers, 110 plus 111. Then you go. The first thing you do is line up these numbers. 110 plus 1. 1, then you go from right to left. So 0 plus 1 is equal to 1. 1 plus 1. 1 plus 1 equals 10. Put your 0 down and always carry your 1 to the next column. Then always add two digits at a time. So 1 plus 1 is equal to 10. This is your 0. And carry your 1 to the next column. Plus 1 is equal to 1, then bring down 1. So this is 1, so 110 plus 111 is equal to 1101. And always check your answer in decimal, just to make sure you got the correct answer to do that. We will use the doubling method. We have 1, 2, 4, and 8. Then add up numbers with ones in the column. For 110, we have 1 under 4 and 2. So 4 plus 2 is equal to 6. And that's the decimal equivalent of 110. For 111, we have ones under 4, 2, and 1. So we have 4 plus 2 plus 1 is equal to 7. And that's the decimal equivalent of 111. For the sum, we have ones under 8, 4, and 1. So we have 8 plus 4 plus 1 is equal to 13, and 6 plus 7 definitely equals to 13. So our answer is correct for our second example. Now let's take a look at binary subtraction. Since we have binary addition, we also want to go over binary subtraction. And binary subtraction works the same way that subtraction works in our decimal number system, or the numbers that we use in everyday life. We're going to subtract from the number above, and if we can't, we're going to have to borrow from the column to the left. So if we take a look at this first example, I know just by looking at it that the number above that I'm subtracting from is larger than the number I'm subtracting, and I can easily go through this number, no problem. So I have 1 in the first one's column. So I have 1 in the first one's column. I have 1 minus 1, and that's going to be a 0. 0 minus 0 is 0. 1 minus 1 will be a 0. 1 minus 0 is 1, 1. Minus 0 is 1, and 1 minus 0. 1 is 0. And we don't have to put that first 0, because it's a leading 0, and there's our answer, and that should be no surprise. That one's pretty simple. Surprise, that one's pretty simple. If we take a look at our second example here, this one's going to be a little bit tricky because we're going to have to borrow, and borrowing is not too bad. It's similar to, like I said, to normal decimal subtraction. So the first side we used to track is the rightmost side, always just like regular subtraction. So I have 0 minus 1. And for this, I have to borrow. So for me to borrow, I have to cross this one out and make it a 0. But when I bring over that one into the column to the right of it, it becomes 2 1s. So it's just the opposite of what you did when you are adding. So now I have 2 1s, one of which will be subtracted. So this one here will be subtracted from this one here. And we would have we would have a 1 left over our next step. We have a 0 minus 1 again, and this time again we'll have to borrow. We can't borrow from the column to the left. So we're going to go 2 columns over. So we're going to borrow from this one. It becomes a 0, and this one would get 2 1s. One of which we're going to borrow, so this one's gone, and we have 2 1s. And we can say that means that we can subtract from maybe this one and this one, leaving again just that single one in the next column. I now have 1 minus 0. That's 1, this one, I have 0 minus 1. And again, we're going to have to borrow all the way from the next one. We find that we'll leave 0. This will leave 2 1s. We're going to cross one out because we're borrowing it for this one, and we're crossing one out to borrow for this one. So we'll have 1, so there's 2 1s, 1 and 1, the 1 down here, and our original. So we'll be left with the remainder of 1 down there. And the next column we have the 1 minus the 1. So we have a 0. Then we have a 1 minus 0. So we have a 0. 1, a 0. Minus 0 is 0. 1 minus 1 is 0. 0. So we don't even really need those 2 zeros, and there's our answer. We will now proceed to octal numbers, which is octal addition. Let's go into an octal addition. So I got a simple example for you here. 5, 6, 7 base 8, 2, 4, 3 base 8. We will now proceed to octal numbers, which is octal addition. Let's go into an octal addition. So I got a simple example for you here. So I'm not calling these 43 and 56 because these numbers don't represent the numbers 43 and 56 as we're familiar with them in decimal terms. We are dealing with octal here. We need the base of 8. So 3 plus 6 is equal to 9. But we can't do that. So we are left with 1. Since we can't carry 8 as well, what we can do is carry to the next digits and represent it as 1.1 lot of 8. Second column here, we have 4 plus 5 with carry. 4 plus 5 plus 1 is 10. Again, we can't put 10 because our base is 8. We are going to carry again. We put down 2 and carry 1 in the next column. 43 to the base of 8 plus 56 to the base of 8 is, or 4, 3 plus 5, 6 gives us 1, 2, 1 to the base of 8. Octal addition is hard, no? Well, don't worry, so is octal subtraction. Just kidding, I'm so tired I want to rest my vocals. Arnold, take over.
Today we are going to discuss galvanized square steel. Transform a 0.1 square meter space into fully functioning house. Little John helped his grandpa hide their treasure and immediately got a house from him. Excited, he opened the door but found the house was only 0.1 square meters. Frightened, he quickly went back to ask his auntie for help. Firstly, he created a frame by welding galvanized square steels to extend outside, then borrowed screws from his aunt to firmly fix it to the wall, added short splices in the middle, and laid professional steel plates. A layer of grid steel mesh was added on top before pouring concrete, durable for 10,000 years. He then installed high-quality aluminum windows. Now, a wealthy Little John can happily dance his ballet in his upgraded 2.6 square meter home. The elevated sitting platform allows storage underneath for his items. He placed a mattress on top to create a bed and added a cushioned backing for comfort. He also put a folding table by the window, which serves as a workspace and dining table without taking up extra space when not in use. He welded a frame with galvanized square steels above. Subtraction in octal number, for example 257 base of 8 minus 165. Now 257 minus 165. Our base is 8. Borrow will be 8 as well. Seven minus 5 is? $2.5 minus 6. We'll borrow from 2.1. Now 8 plus 5 minus 6, 7. 1 minus 1 is 0, 0. Answer is simple. The answer from subtraction in octal number system example 257 minus 165 with both base of 8 is 072 or 72/72. We will now proceed to adding and subtracting hexadecimal part, hexadecimal addition. In this case, once you go above 9, which is 10, it'll count as 10 is equals to A.
Look at the sample shown. We'll try decipher the equation. FA0219 plus FDA29. You have 1 through 9 and A is equal to 10, all the way to F, which is 15. Start at the rightmost side, which is 9 plus 9 divided by the base of 16, 18 divided by 16 is once, with 2 left over. We carry the remainder, so 2 plus 1 will be 4. Now A plus 2 is 12. And we know that 12 is equivalent to C. So we'll write C, D plus 0 is just D. A plus F, A is 10 plus F, which is 6, 15, so 10 plus 15, 25. 25 divided by 16 is, it'll go with once to leftmost F, and once with 9 left over. Lastly, F plus 1, F is 15, plus 1 would be 16. So 16 divided by 16 is just 1. That is all you need to do when adding hexadecimal. Last, but not the least, demonstration on how to subtract hexadecimal.
Based 16 with letters. The process is pretty much the same. Okay, let's try.
9 minus D cannot be, means we have to borrow. E needs to be reduced to 9. 9 will now be 9 plus 16 is equals 25. First column is 25 minus D equals 25 minus 13 equals 12. "12 is equivalent to C based 16. Second column, 9 minus B, same thing happens. Borrow from third column. E is reduced by 1 to D9, same thing happens. Borrow from third column. Is 25. 25 minus B equals 25 minus 11 is equals to 14 equals E based to 6. D minus F cannot be again. Borrow from leftmost D, which will be decreased by one value. D will be C, 13 plus 16 will be 29. 29 minus F is equals to 14, E based to 16, last column, C minus 4, C is 12. 12 minus 4 is equals to 8.
And there you have it, folks. Question and answer is highly suggested. Let us know what you think about our presentation. All rights reserved and remains to the rightful owner. Thank you, and God bless.